All right. So I'm on the journal that we started yesterday, and we're going to go ahead and finish it. Addie, can you get the lights for me, please? All right. So we talked about histograms and we talked about dot plots. What is a dot plot the most or the best used for? What do we typically use dot plots for? Well, all that we use for data. But what makes a dot plot good to look at the data? Like, what does it show us? Oh, right. So, what does a dot plot typically do? Can someone at least tell me what a dot plot is? Right. So, a dot plot is just a graph, almost like a number line, that keeps track of how often something happens within a certain category. So, you weren't here yesterday. So, for example, like let's say we were talking about how many minutes that a class works on homework if we took a survey. All right. The dot plot would go through the different minutes, like how many people said 12, how many people said 15, whatever. All right. So that's a dot plot. It's just a good way to organize more categorical data. What about a histogram? What does that really show us? What's the difference between a histogram and a dot plot specifically? Well, it shows data just like a dot plot. Both of them show data.
One's a number line and one's a graph.
Technically, they're both graphs. But a histogram looks like a what? It looks like a bar graph. Now, what's so special about a histogram? What separates a histogram from a bar graph? The bars do what? So, when you guys typically see a bar graph typically looks like this. Histogram, on the other hand, looks like this. What's the difference? One connects the bars, the other one doesn't. Why do you think that is? How do we typically have to start our histogram? What do we have to do first? We have to make a what? A frequency table. Now, within those frequency tables, what were we looking for specifically? The what? The range. So most of our frequency tables was if a number fell within a certain range of numbers. So for example, like the first one we did yesterday, we were looking for which one fell between like 18 to 20 minutes, 20 to 22, so on and so forth. That's why the histogram bars connect, because it's almost like a flow chart. It keeps on going. It flows into the next category. Whereas a bar chart or a bar graph, it's clearly discrete. Like they don't connect to each other at all. This would be like if I was saying, okay, only one, if we only have 1 minute, 2 minutes, 3 minutes, there's no connection. We're not looking for a range. This many people had only 1 minute, this many people had 2 minutes, this many people had 3 minutes. Whereas a histogram says, okay, so this first bar represents how many were between 1 and 3 minutes, 3 and 5 minutes, 5 and 7, 7 and 9. All right. It goes and flows into the next category. It's all connected. All right. So histograms are better used for when you have a range of numbers and you just want to see kind of what we'll find out later on when we talk about outliers, how it's skewed, what the data is looking like, how it relates to each other, a bunch of different stuff. All right, so dot plots are more similar to bar graphs where they kind of organize the data in a discrete way where we can see clearly how many in each category. Whereas a histogram is more continuous where we have a range of numbers and we're trying to see how frequently that range of numbers happens. All right. Now, box plots and two-way frequency tables are even more different from these two. So, does anyone remember box plots back in 8th grade? Well, a lot of your 8th grade teacher is saying that you guys should. Does anyone remember at least what a box plot looks like? You may have heard of box and whisker plot. Right, a box plot kind of looks like this. That's not the prettiest box plot, but it kind of looks like that. All right. So remember, a box plot is a good way to organize a lot of the measures of central tendency. And by measures of central tendency, I'm talking about the mean and the median and its quartiles. All right. So we're going to review all of that information. All right. So let's go ahead and start with the box plot. So go ahead and open up that plot. That's where we're going to start. All right, so I'm on the very first box plot. Now, with the box plot, we're looking at the points scored by the Inverness Middle School's football team last fall. And these numbers right here are our data set. So this is our data. Now, does anyone remember what we need to start with to start a box plot? We need to find a couple of things. Can someone name me at least one of those things we need to find? We need to find the lowest number. What else do we need to find? The highest number. So in other words, we got to find the range between the lowest and the highest. What else do we need to find? The middle number, what's that called? The median. All right. What else do we need to find? Mean doesn't really come into play here. Well, the order of the numbers, we do need to reorder the numbers in numerical order. But there's one last thing. It starts with a Q. Does anyone remember what that keyword is? You guys remember quartiles? So, quartiles, there's two of them. You have the first quartile and the third quartile. Essentially, quartiles are just basically the medians between the lowest number in the median and the highest number in the median. All right? So, in other words, we got to have what we call a 5-number summary. All right? So, we have to have the 5-number summary. That's how you always start a box plot, with your 5-number summary. And in that summary, you need 5 things. You need the minimum number. You need the first quartile. You need the median. You need the third quartile. And you need the maximum. Now, why do you think when I'm talking about quartiles, why do I just jump from first to third? What happened to the second? What technically is the second quartile? The median's technically the second quartile. That's why we don't say second quartile, we say third. All right? Because remember, these 3 things are what make up the box.
So this is what makes up our box. Whereas these two make up our whiskers. So that's going to be a whisker and that's going to be a whisker. So whenever you start to do your 5-number summary, you always start by putting your numbers in numerical order. So from least to greatest. All right. So if we're going from least to greatest, what should be my first number? 13. All right. And we have a couple of 13, so we're going to state all of them. So 13, 13, and that's it. All right. What's my next number? 23. And we have a couple of 23s, so I'm just going to keep stating them. What's my next number? Somewhat different. 24. Then 27. And we have a couple of 27, so I'm going to state them. What's next? 30. We have two 30s. Then what? A couple of 34s. And then we have our last number, which is 55. So you always start by putting the numbers in order. Why do we want to put the numbers in order? Why is that important? So why do we have to put those numbers in order? What makes that so important? Let me ask you guys this. If you were to find the middle number of a data set, if I just took the middle number from the original data set without reordering, would it truly be the middle number? No. That's why you have to reorder it. Because with median, especially, and your quartiles, you need to know the true middles. All right? So, what number is my minimum? 13. So 13 is my minimum. So 13 is your min. What's my max? 55. Now, median. Take a minute, find the median. What would it be? It'll be what? 27. Because if you start crossing out on each side, I'm just going to do it above it so we don't cross out the numbers. You'll end up with two numbers left, which if you have two numbers and they're different numbers, so this time it's the same number, but if they were different, what would you have to do to find the true median? Nope. So let's say those two numbers was 27 and 28. How would I find the true median? How do I know which one to pick? You'd have to do what to the two numbers? Find their what? So guys, this is a review from not only middle school, but elementary school too. So technically, the middle or the mean is right here, not the mean, the median. But let's say that one of those numbers was 27, the other one was 29. What would be the true median? It would be 28, but how'd you get it? Nope. What if it was 27, 28? But how would you find it mathematically? What if it was between 27 and 30? Guys, you would take the mean of the two numbers. You would add them together, divide it by 2. That would be the median. You guys remember that? Yes, no, maybe? All right. So if that was the case, so we know it's 27 because it's the same number. But if we didn't, we would add up the two numbers. Or do 27 plus 27. And then divide it by 2. We would take the average of the two numbers. It's still 27. All right. So the median in this case is 27. Now we have the minimum and we have the median and we have the max. Now we have enough information to find the quartiles. How do I find the quartiles? How would I find the first quartile? I would have to do what? So the first quartile is somewhere between the minimum and the median. In fact, it's halfway between them. So what do I need to do? You're close. You find the median between the min and the median. So we take the median again, but just between the min and the median. So it's almost like the boundaries. So essentially, if we went back and forth, all right, we'd end up with 23 as our first quartile. So to find the quartiles, you find the median between the minimum and the median. So you find the middle between the minimum and the median. That's for the first quartile. So my first quartile is 23. You find your third quartile the same way, except you're finding the middle between what? The max and the median. All right, so take a minute, find it. Find that third quartile. Did you guys find it? What is it? 32. How'd you get 32? Right. So when you did the median of both, you ended up going between 30 and 34. So to find it, you would add 30 and 34 and divide it by 2, and that would give you 32, which is our third quartile. So that's why I was telling you guys earlier, if you're between two numbers, you've got to find the mean of those two numbers, or the average. So now I got my five number summary, so I can go ahead and start plotting it. So whenever I do my 5-number summary, I usually want to start by making my box first. So remember, your box is your first quartile, your median, and your third quartile. So I usually like to do the first quartile and third quartile first, because that kind of marks the limits of my box. So the first quartile is at 23, so I would say that's about right here. Your second quartile is the median, which is at 27, which is about right here. Remember, you still draw a line for your median. And then your third quartile is at 32, which is about right here. So our box will look something like this. So again, this is your first quartile, or a lot of times we call it your Q1. This is your third quartile, which is Q3. And this is your median, which we also call Q2. So median, another name for it is quartile or second quartile. Now, where do the whiskers come in play? They come from our what? Our minimum and our maximum. So I'm going to mark where my minimum is, which is at 13. So that's about right here. And then I'm going to mark where my maximum is, which is at 55. So that's way over here. And then I'm going to connect it to my box. So when we're looking at a box plot, what do we typically want to look for in a box plot? Does anyone remember what a box plot is used for? So box plots a lot of times tell us how our information is skewed. All right. It can also help us find outliers. All right. And by doing that, that's when we use the IQR. Who remembers what the IQR is? The formula for the IQR. It's okay. We don't have to do that right now. That'll be part of tomorrow's lesson anyway. All right. For right now, though, you do need to know how to at least make the box plot. So this is your minimum. This is your max. All right. Any questions on actually making the box plot? All right. Let's look at another example. So, for example 6, I want you guys to go ahead and make your 5-number summary on your own, and then make your box plot. I'll give you guys about 5-6 minutes to do that. All right. So go ahead and get started. So you guys got it? So guys, go ahead and make your box plot once you get the 5-number summary. Luckily for us, this was already in numerical order, so we didn't have to do that. All right, thumbs up if you're ready. All right, I'll give you guys one more minute. All right, check your work. So my min was 74. My Q1 or first quartile was 75.5. My median was 83. My Q3 or third quartile was 86. My max was 99. And my box plot looked something like that. Any questions how I got any of those numbers? So the only issues that you guys should have ran into was with the two quartiles because they fell in between two numbers. Now this one was pretty easy because halfway between 85 and 87 is 86. You still should have taken the mean though just to be safe. This one you would have definitely had to do 75 plus 76 divided by 2 to get that 75.5. All right. Now, for the last example, I'm going to show you the calculator way on how to get your 5-number summary without actually having to find it yourself. All right. It comes incredibly handy with big data sets. All right. But since the last one is probably our smallest data set, I'm still going to show you how to find it because it's just a little bit easier to put in the calculator. So this is where you're going to want your green sheet. All right. The steps that I'm referring to on your green sheet are the ones that say to get statistical information. All right. Those are the steps I am referring to. So in your calculator, we're using example 7's data sets. All right. The first thing we got to do is actually input our data set. Everyone should have their calculator out and everyone should be doing this along with me. All right. The very first step is to hit the stat key like we've been doing for almost everything statistics. So we're going to hit stat, and then we're going to hit enter so that we're editing our chart. Now remember, if you have anything in your columns, to get rid of them, all you do is hit the up arrow key so that the L1 or L2 is highlighted and hit clear, and it goes away. Same thing if you have more than one column filled out. You just hover over the L1 or L2, make sure it's highlighted, hit clear, it goes away. Is everyone at this step so far? So everyone should have their calculator in their hand. trying this. Now, take a minute and you're going to input all of the numbers into L1. All right, so all of our data, for example 7, is going into L1. So go ahead and take a minute and input those numbers. So remember, just type in a number, hit enter. That's how you input it. So once you get all your numbers inputted, stop. So unlike with regressions, we're only filling in one column. So everyone should be putting this in their calculator. The only way you'll learn how to do this is if you practice it yourself and put your fingers on the keys. All right, has everyone gotten through to this step? All right, now this is where the steps on your green paper come in handy. So the next thing you're going to do is you're going to hit stat again. You're going to hit the right arrow key so that calc is highlighted. So now we're doing the calculation side of it. And this is probably the easiest thing for you to remember. Do you see how this top one says one variable stats? That's what one var stats means, one variable stats. All right, all you're going to do is hit enter. All right, and then you're just going to hit enter a couple times until it goes in. So there's a couple of things in here that you may or may not understand. So you may get this screen at first. Now, on your green sheet is the label of what all of these symbols mean. So X with a bar over it, that's actually your mean. So if you ever need to find your mean, this is your mean. All right. These other 4 things we'll talk about later. N represents the number of items in the set. But if you scroll down, look at what it gives us right here. If we scroll all the way down, what does it give us? Our what? What are these 5 numbers called? Your 5-number summary. So hit your down arrow key till you see all of this. And just like that, we have our 5-number summary, and we didn't have to do anything by hand. So this box and whisker plot will be easy to make because all we're doing is almost copying and pasting. So our 5-number summary for this one, what did it say my minimum is? 52. What did it say my Q1 is? 70. What did it say my median is? 72. What did it say my Q3 is? 76. And what was my max? 78. So we got all the information we need to make a box plot. So I'm going to go ahead and graph it very quickly. So there's my minimum. There's my maximum. My Q1 is at 70. My median's at 72. My max is at 76. So it would look something like this. So if you ever need to do a box plot, and it's especially with a big data set and it's not in order, your 5-number summary can be done for you if you put it in your calculator. So again, it's very similar to if you were doing a regression in your calculator, except you're only filling in L1, and then when you hit calc, you're just going to hit enter as soon as it's on the calc side. All right. One last thing. If you ever need to look at your box and whisker plot using your graphing calculator, this is what you'll do. Very similar to what I told you about yesterday with your histogram. So I'm going to clear out of this. Our table is already saved in our calculator. So I'm going to go all the way up to second and then y equals to get my stat plot. I need to make sure that plot 1 is turned on. So I'm going to hit enter and click on. Now, do you see this one right here? That is our box plot. So I'm going to use my arrow keys to get to that box plot. So this is the one we want to use, the one that looks like a box with a line in it. This one is outliers. We'll talk about that next week. But we only care about this one right now. So I'm going to hit enter. And it's telling us to put this in list 1. And then I'm going to hit enter again and graph. Now, we may have to zoom out. So I'm going to hit zoom 9 so I can see it. And just like that, there's my box plot. Now, it may be hard to tell what the numbers are but at least we can kind of get an idea of what it looks like. All right. So when we talk about how outliers affect things, like with skewing, we may just need to just see the box plot. All right. And those steps I just did were the same ones that we talked about yesterday to plot histogram and box and whisker plots. All right. Any questions on that? All right. So we're going to go ahead and take our 5-minute break. When we come back, we'll finish 2-wave frequency tables. That one's quick. So remember, be back before the timer goes off.
Yeah, yeah, I got it.
Does anyone know where Miss Bishop's room is in here? Okay, Olivia, can you go down to Miss Bishop's room and ask Miss Jordan who's in there for where Miss Jordan she has.
Miss Kelly says go that way.
Miss Kelly says love.
Yeah.
Why don't you do what she's told?
Yeah, that's what we love you when we do.
I'll be a pretty good anyway.
I didn't. I'm sorry. Me and this one just have a special connection.
Go away.
Okay, well, you can finish that after.
All right, guys, break's over. Heads up. Let's get back to work. All right. So, last thing we're going to talk about is the two-way frequency tables. Now, these are a little bit more straightforward, so this won't take very long. All right. So, two-way frequency tables. Basically, a two-way frequency table is exactly like a regular one-way frequency table, except we have two different categories. So, in other words, for example, Jenny surveyed 100 of her classmates on hair and eye color. So, up top is most likely our hair color, and on the side is our eye color, and it's where they overlap. So, in other words, this first number would represent 18 people had both blonde and blue eyes. All right. Now, your totals, all right, these totals represent how many total for each hair type, because that's where the columns end. And this total right here is how many for each eye color. And this 100, that is the overall total. So this right here is the overall. So both of these totals should add to 100 in order to be correct. Now, the columns inside, so right here, these little columns right here that are not highlighted, these should all add up to their respective, each column should add to their respective blue, and each row should add to their respective blue. All right. So if we were to fill in the frequency table, all right, let's start with the blue eyes. So there should be 28 people total that have blue eyes. We know that 18 of them are blonde and 9 of them are brunette. So how do you think we're going to find how many have red hair? How many blue-eyed people have red hair? What do you think we're going to do? Right. We'll add up the two categories that we already have and then subtract that from 28. So 18 plus 9 is 27. So to get this one, we're going to do 27 or 28 minus 27. And the 27 came from adding these two categories together. And 28 minus 27 is 1. So only one person had both red hair and blue eyes. All right. Now, in order to figure out where to fill in next, you always want to look for where basically everything in that row or column is already filled out except for one thing. So where next would you want to try and figure stuff out? So look for a row or a column that has all the numbers in it filled out except for one box. So brown eyes, blonde hair. We could do that one, but we would need to find this number first. But we can find that number first because if all of these blue totals have to add to a 100, how can I find this one blue box? Subtract it. So add it and then subtract it. So I'm going to add the 28 and the 31, and that would give me 59. So I would do 100 minus 59, what's 100 minus 59? 41. So now we can find blonde and brown hair because we know that the total for brown eyes has to be 41 people, and we have the two other numbers. So find how many people have both brown eyes and blonde hair with the information that we have. Did anyone get it? So to get us started, we're just looking at the row that says brown. All right, so we're just looking at this row right here. It has to add all three of these numbers that are white have to add up to this blue number 41. I have 2 out of the 3 numbers, so what do I need to do to find it? What have I been doing? Adding them up and then subtracting it from the total. So what number would you get for brown and blonde? 13. That is correct because 23 plus 5 is 28. You subtract that from 41, you get 13. All right. Where's another spot that I can fill in? So can we fill in any of the hazel row just yet? You sure? We can't really fill in the hazel row, but we can still fill in some of the boxes because we'd be completing some of the columns. Which column could I complete? So red hair, we can complete this column because we have the total and then 2 of the numbers. So same process. Add up the 2 that you're given, subtract it from the total. So what do you get? 6. Because 1 plus 5, we add these up and subtract it from 12, which is 6. I can also find the brunette by adding 23 and 9 and subtracting it from 48. So what would that give me? 16. Oops. Now I can find my last hazel eye by doing what? Adding 16 and 6 and doing what? Subtract from 31, which would give you what? 9. So my last total would be what? 40. You would add up 18, 13, and 9. So that's how frequency tables work. So in other words, this section right here deals with hair color, whereas this section right here deals with eye color, and they all got to add up to that 100. So all of the sections have to add up to this 100. Does that make sense how to fill in a two-way frequency? So again, easiest way to do it, find columns where 2 out of the or 3 out of the 4 columns are filled in, or basically most of the column or row is filled in except for one box. That's the easiest way to find them. All right. Any questions on example 8? All right. Example 9. Got to do a little bit of legwork here. So it's completely not filled in, but we can easily figure out what goes where. So that's from what is in the word problem. So 150 students in a survey, 40% said they had a cat. Of the students that have a cat, 60% also have a dog. Of the students that do not have a cat, 80% have a dog. So that was a lot. So we're going to kind of work our way backwards. So again, if I was to highlight these boxes, we want the cat category would be here. The dog category would be here. And then our total would be here. So what's our overall total? Do we at least know that? It's 150. So the pink square we can already go ahead and fill in. It's 150. Now, the next step, what do you think the next step I would use to find? What part of this problem would be the most logical step to do next? So I would go with the next part of the sentence. 40% said they have a cat. Because if I find 40% of 150, so 40% of this 150 have a cat, that means that number would fill in which one of these squares? The cat what? Total. So we can get the cat total from the 40% of 150. How do I find 40% of 150? Nope. So let's think about this logically. All right. If I was at a store and I was buying, say, a dress for $100, that was the original price, but I get 20% off, how much am I actually paying? So the dress is $100, but I had a coupon for 20% off. So how much money did I actually pay? 80. So how much money did I save? 20. How'd you know it was 80? How'd you figure out what 20% of 100 was? Well, there is some subtraction there. But let's say I had the dress was $50 and I won 20% of it. I had 20% off, so how much did I actually pay? So guys, this is actually money cents. All right. All these sales that you guys have whenever you go shopping, whether it be online or in person, this can deal, even though it's talking about cats and dogs, this can also relate to money. Let's say a dress was $150 and I got 40% off. How much money did I save? How would you find it? How would you find how much money you took off of the original price? You'd have to multiply the 150 by point what? What's 40% as a decimal? 0.4. So we would multiply 150 by 0.4 to find out what 40% of 150 is. So 40% is 0.4 as a decimal. So to find 40% of 150, I would do 0.4 times 150, which is what? You put that in your calculator, what do you get? So 60. So that means my total number of cats was 60. 60 people had a cat. Which means how many people had no cat? So 60 people had a cat, 150 people total. How many people did not have a cat? 90. So just like that, we filled in 2 boxes. Now we can look at the next part of the statement to fill in some more. So the next part, of the students that have a cat, 60% also have a dog. So of the people that have a cat, they also have a dog. So I'm looking to fill in this first box right here. Now, we're going to do something similar to what we just did with the 40% of 150. But now I'm taking 60% of what? Am I taking it of 150 or a different number? You're taking it of 60. Why? Why are we taking 60% of 60 and not 150? What did the problem say? Right. Of the ones that have a cat. So in other words, if they have a cat, they also have a dog, 60%. So we would do 0.6 times 60, which would give us what? 36. So this box right here is 36. So now I can fill in the number of people with a cat with no dog. How many people that have a cat do not have a dog? 24. Now we can have our last statement. So our last statement says the students that do not have a cat, 80% have a dog. So in other words, if they don't have a cat, 80% have a dog. So we're filling in this box right here. So what do I need to take 80% of? 90. That's of the people that don't have a cat. So 80% of 90, so I'm doing 0.8 times 90, which is what? 72. Now I have enough information to fill in my last 3 boxes. So how many total people had a dog? Total people that just had a dog, not 150. It's 108. You just add up 36 and 72. How many people had no cat or no dog? Say it again. It would be 18. We would just subtract 90 and 72. So how many people had no dog total? 42. And then to check, 108 plus 42 does give us 150. And just like that, we filled in our frequency table. So, very, 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 very quick recap on that last slot. So this just explains what is going on. So we use a dot plot to show frequency and distribution of the data. And we'll talk more about distribution later. We use a histogram to look to see a set of data values that are closely grouped. With no outliers. Again, we'll talk about outliers later. And that use the mean to show the center of the data and the standard deviation to show the spread of the data. So we'll talk about spread later on. All right. But just for reference, this graph right here would be what we call symmetric. And this graph here would be skewed. And technically it's to the right. And again, we'll talk about what that means later. That's a different lesson. I just want you guys to at least write that down for right now. Now, box plot shows a set of data values that are spread out. And they use the median to show the center of the data and the interquartile range, which we'll talk about later, to show the spread of the data. And just to recap what's what, this is the min, this is the first quartile, the median, the third quartile, and the max. And then finally, we have the two-way frequency table. All right. Now, frequency tables just show frequency of more than one variable, specifically two. And just some quick vocabulary. The stuff that is our overlap. So where the two different categories overlap. This is known as our joint frequency. So all those numbers will be considered the joint frequency. Now, the totals of each category is known as your marginal frequency. So whether it's the totals of the rows or the totals of the columns, those are known as your marginal frequency. And then the 32 is just our overall total, or our sample size. All right, any questions on any of the distributions? All right, so you should be able to finish that delta math that I assigned you yesterday. You guys got about a solid 20 minutes. All right, so go ahead, take out your Chromebooks and get started. And I'll go ahead and post the exit ticket too.